Alright, so now we're going to have a look at some problems where the outer function is an exponential function. And so what do I mean by that? Well, let's look at this problem here. How would I decompose this function, right? So what's my inner function? What's the thing, if I had a really bad calculator and I couldn't do everything at once, what's the first thing I would have to type in? The inner function here is this thing up top. There's kind of like parentheses around that, right? It's kind of inside parentheses is the first thing I have to do. It's negative x squared plus 1. And my outer function here then would be just e to the x, right? And so remember the idea here is that if I do f of g of x, I'm going to get this thing up here, right? So if I take this x and I replace it with g of x, so if I take the input of f and replace it with all of g of x, I get what I started with. Right? And so that's what we want to be able to do. And so remember what the chain rule tells us. It tells us that the derivative of f of g of x is equal to f prime of g of x times the derivative of the inner function. So what it's saying is take that derivative of the outer function and then multiply it by the derivative of the inner function. Now, so e is a very special case, right? What is the derivative of e to the x? The derivative of e to the x is just e to the x. So by taking the derivative of the outer function, I get left with the same thing, right? If I had said take d over dx of e to the x, you'd just say, well, Dan, that's super easy. That's e to the x, right? And so this, just like that, our first part is still super easy. E to the negative x squared plus 1. That's this part. Right? But the chain rule says, well, you have a little bit more work to do, right? You need to multiply it by the derivative of the inner function, which I figured out was negative x squared plus 1. Right? And so the derivative of the inner function here is actually just negative 2x. And you could write plus 0, but you don't really have to, right? So the derivative of negative x squared plus 1 is really just negative 2x plus 0. And so if I want to simplify this thing, that 0 kind of goes away and I end up with negative 2x e to the negative x squared plus 1 as my derivative. Okay, so let's look at a different exponential, right? So one where I have e, not e anymore, I have 3 to the t squared plus 1. Let's do the same thing where we identify our inner and our outer function. So just like before, I want you to realize there's kind of parentheses up here. There's like implied parentheses, right? So my inner function is t squared plus 1, and my outer function here is 3, and it's not g of x. My outer function is 3 to the t, right? So the first thing I have to do is I have to take the derivative of my outer function. I have to imagine this thing was just a t. And what would I do to take the derivative of my outer function? Well, if we follow our rule from, I believe it was the last section, the derivative of 3 to the t is just the ln of 3 times 3 to the t, right? Except here, it's not just t, it's 3 to our power of our inner function, right? So this one's a lot harder to see, right? So let's just kind of recap this form, right? So f of t is 3 to the t, so f prime of t is ln of 3 times 3 to the t. But I don't write f prime of t first, right? I write f prime of g of t, right? So I have to replace this t here with g of t, right? So this is the first part that I've already underlined, right? And now I've taken all the derivatives I need to over here, but in the last part, I still need to multiply by the derivative of t squared plus 1. I'm not done taking derivatives here yet. I am done taking derivatives here. So in the end, this is going to be equal to the ln of 3 times 3 to the t squared plus 1. And then I have to multiply that by, now remember your parentheses, and this is just going to be 2t plus 0 again. And so if I simplify that out a little bit more, is going to be 2 times the ln of 3 times t times 3 to the t squared plus 1. And you do not have to write your 3 like that. All right, so let's look at one more example, but just remember we're following this general form of kind of take your derivative of your outer function, kind of your easier one in this case, and then multiply it by the derivative of your inner function. So here's another one. So let's decompose it again. So what do we do with this 6? What do we do with this 6? So I think we had an example like this in the power functions. And notice that this is just this is a constant times something that I know how to take the derivative of, right? So I can actually just pull this 6 out there, right? And I'm just going to write this. I'm really doing 6 times d over dx. I don't really need to worry about 6 when I'm taking the derivative. I just multiply it by the derivative in the end. 5t cubed, 5 to the t cubed plus t. And so the inner function here, if I stopped mixing up my letters, would be g of t would be equal to t cubed plus t, and f of t would just be 5 to the t, right? So if I take f of g of t, I get what I had up here, right? So f of g of t, so I replaced this t with g of t. And so remember, my chain rule formula tells me that the derivative of f of g of t is equal to f prime of g of t. So I need to figure out what f prime is first. So the derivative f prime, if I wasn't thinking about my inner function at all, it would just be the ln of 5 times 5 to the t. So that's what I'm going to start out with writing. I'm going to write out the ln of 5 times 5, except I don't want just to the t. I want g of t in there. So 5 to the t cubed plus t. And the chain rule tells me I need to multiply this by the derivative of what's on the inside. So multiplied by d over dt of t cubed plus t. Right? And so I'm done taking derivatives here. I've taken all the derivatives I need to, and the only derivatives I still have to worry about are over here. So this is going to be equal to, the first part stays the same, and the derivative of t cubed plus t is just going to be 3t squared plus 1, right? And this is basically as simplified as you can get this one, right? So hopefully this video kind of helped you kind of get used to some of what functions will look like when the outer function, when this f, is an exponential.